Hello, I am Jing. In this video, I am going to use a program to solve a question. The question we are solving is, a policewoman is assigned to control the traffic at 9 intersections indicated in this figure. The question says 9 intersections by this figure. There are only intersection number 1 to number 8. So we let this position where the policewoman is standing to be intersection 1. And the number of all other intersections will plus 1. And hence, we will get the position from 1 to 9. Now, we continue to look at the question. The policewoman is instructed to remain at each intersection for an hour and then to either remain at the same intersection or move to a neighboring intersection. To avoid establishing a pattern, she is told to choose her new intersection on a random basis, with each possibility choice equally light. Every day, she starts at the location where she stopped the day before. Our problem is when the user input n equals to 1, 2, 3 until 10 and gives the starting position of the policewoman, the program should output the probability of the policewoman is at all 9 locations after n days. In order to solve this question, we need to know how to find the probability of the policewoman is at all 9 locations. So based on the theorem, we know that we can find the probability from this equation. X power of n equals to p power of n times x power of 0. The x is indicating the probability of the policewoman is at all 9 locations. Hence, x power of n is the probability that the policewoman is at all 9 locations after n hours, while x power of 0 is the initial location of the policewoman. Next, P is the transition matrix of the Markov chain. So we already know how to find the probability. What we need to do now is just substitute the number of hours into this equation. Remember that 1 day will equal to 24 hours. In this slide, I will explain about how to find the transition matrix of the Markov chain. For the first column, it is the probability of the policewoman is at all 9 locations if her previous position is at position 1. So you look at the diagram. When the policewoman is at position 1, she has equal probability to move to here, here, and here. So in the transition matrix of the Markov chain, it will have equal probability to be at position 1, position 2, and position 4. And then let's see the second column. Second column is the probability of the policewoman at all 9 locations if her previous position is at position 2. So let's see the diagram. When she is at the position 2, she has equal probability to move at here, 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 and here. So in the column 2 of the Markov chain, it will have equal probability to be at position 1, position 2, position 3, and position 5. And use the same way to find the column 3, 4, 5, 6, 7, 8, 9, and you will get the transition matrix. Now, let us move to the program part. I have used the programming C++ to do this question. I will first run this program and then explain about how this program works. When we are running the program, it will first declare the question and allowing us to choose the unit of time we want to use, whether days or hours. We can type 1 or 2 to choose. Now we choose 2, indicating we are choosing hours. And then we input number of hours and input initial position. And then the final probability will come out. It will display the probability in a column first and then explain it. Saying that the probability of the policewoman in position 1 is how much probability, in position 2 is how much probability, in position 3, 4, 5, 6, 7, 8, 9 is how much probability. Next, the program will ask the user whether the user wants to repeat to use the program again or no. Now we choose no, and the program ends. Now I will explain about how this code works. First of all, I declare 3 float variables, which is A, B, and C, and let them to become 1/3, 1/4, and 1/5. I do this because I need to use them in declaring the transition matrix of this Markov chain. Then I declare the 9 times 9 transition matrix of the Markov chain. And then also declare a Boolean variable repeat, red indicating repeat. First of all, we have a do while loop. It will do this all code first and repeat to do this code again if the Boolean variable repeat is equal to true. Hence, I declare the variables needed in the program and print out this message to the user. These are explaining the question to the user. And then let the user to choose the unit of times that him or her want to use, whether hours or days. If the user enter 1, then the program will prompt out this sentence. And let the user to input the number of days, and most can input 10 days. If the user input is not in the range, then the program will tell the user about the invalid input and then allow the user to input again by repeating this block code with a do while loop. Hours, the variable hours will be set to number of days times 22, indicating that one day we have 24 hours, right? If the user enter 2, the program will prompt out this sentence and let the user to input the number of hours. At most can input 240 hours. If the user input is not in the range, then the program will tell the user about the invalid input and allow the user to input again by repeating this code with a do while loop. If the user input an integer other than 1 and 2, the program will also tell the user about the invalid selection and then repeat this block code with a while loop. Then the program will let the user to choose the starting position of the policewoman. There are only 9 positions, so the user can input an integer between 1 to 9 to choose the initial position. If the user input an integer other than 1 until 9, then the program will tell the user about the invalid input and allow the user to input again by repeating this block of code with a do while loop. Then the program will set the initial position of the question. Then declare a new matrix P to store the transition matrix power of number of hours. The hours here is indicating powers. For example, when this hours is 5, then P is the transition matrix power of 5. Next, we start to do the matrix multiplication. The final matrix we are aiming to get is transition matrix power of number of hours. For the transition matrix power of 1, it is just the transition matrix. So the program will set each element of the corresponding value of the transition matrix to the matrix P. This done in this block. Next, it will only move to this block code to do the calculation for the transition matrix power of more than 2 if the number of hours that user input is more than 1. The program will first set each element into 0 first before the calculation to prevent that the elements from having a random initial values. Because we are adding it here, we need to add it here. The calculation of the matrix multiplication is like this. Element 1, 1 is the sum of every first row element of the first matrix times corresponding first column element of the second matrix. Then the program will do the calculation for matrix element 1, 2. This element is the sum of every first row element of the first matrix times the corresponding second columns element of the second matrix. And this goes on until it calculates the 99 element. The calculation of the transition matrix power of 2 is transition matrix power of 1 times transition matrix. For calculation of transition matrix power of 3, it is the transition matrix power of 2 times transition matrix. For transition matrix power of 4, it is the transition matrix power of 3 times transition matrix. And this goes on until the transition matrix power of number of hours is found. Then we found the final probability by multiplying the transition matrix power of number of hours with the initial position. And then the program will print out the final probability to the user. Finally, the program will ask the user whether if the user wants to repeat again or not. If the user chooses 1, then the Boolean variable repeat will equal to true, and the program will repeat. If the user chooses 2, then the Boolean variable will equal to false, and the program will end. If the user input anything else from 1 and 2, the program will tell the user about the invalid input, and then repeat, and then allow the user to input again by repeating this block of code with a do while loop. And then this is the end of my explanation about the program. Before the ending of the video, I have something to talk. Look at this. Actually, when the n, which is the number of hours, is big, the probability will converge. As you can see, when I choose days and I choose 1 day, which indicating the n number of hours will equal to 24. And the probability will like this. And when I choose 2 days, and the probability and the number of hours n will equal to 48. And the output will become like this. It is more or less same with this probability. So when it's 3 days, the probability also really close. Really close. 4 days also. So when the number of hours is very big, the probability converge. Only when the number of hours is small, it will have a big difference, like this. The number of probability is the number of hours is small, so the probability have a big difference. So the question want to find the n equal to 1, 2, 3, 4, 5, and 10 days. So because the days is big, because when choosing days, the number of hours will be big. So the probability come out with more or less is the same. So this is the end of my video, and thank you.